Hi, everyone. Here's part 3 of our chapter 10.2 chapter on radicals. This should be a pretty quick video. This is the last one. Talk about rationalizing the denominator. So rationalizing the denominator is something I've said is not the end all. Not something we really should be requiring to do anymore. But if you think about it, an irrational number like root 2, if we're going to make groups of that, that's what dividing is. Put 1 into groups, this many groups. If this is an irrational number, it's hard to put that into groups. So we don't like leaving radicals in the denominator for that reason. So for this course, this is a required skill, and certainly one that they expect in geometry and algebra 2. So in order to simplify a radical fully, you need to have the radical, the radicand, that's the part inside the radical, to not have any perfect square factors. You can't have any fractions inside the radical, such as here. Here's a fraction inside a radical. This is square root of 3/7. And you shouldn't have a radical in the denominator at all. So this is what's going to be called rationalizing the denominator. So in order to rationalize the denominator, we want to make the denominator a rational number, not root 2. So to do that, we're going to multiply this fraction by a value of 1. We're not changing the value of the fraction at all because we're going to multiply the fraction by the same thing in the numerator as we do in the denominator. So I'm going to choose radical 2. So we're going to multiply both the numerator and the denominator by radical 2. And when we do that, we get radical 2 over, well, root 2 times root 2 is root 4. I don't expect you to ever write this step out again. We wind up with radical 2 over 2, and we're done. The denominator is now a rational number, and we like that because we're not allowed to leave irrational numbers in the denominator. Example 2. We might want to think of this as root 3 over root 7. Now root 3, of course, there's nothing we can do with that. Root 7, there's also nothing we can do with that, except it's in the denominator. Root 7 is in the denominator, so we will multiply this by root 7 times root 7. Or, sorry, we're really multiplying this by 1 root 7 over root 7. This value that we're multiplying this fraction by is equal to 1 because it's got the same value in the numerator and the denominator. Now, notice in both cases, I've picked the denominator value to multiply by, the denominator value to multiply by. So we wind up with root 21 over, well, square root of 49, but I'm not going to write square root of 49 because this always comes out to be whatever is in the radicand. Here's another example. 2 over radical 8x. So radical 8x. Now that radical 8 has a perfect square in the denominator. So I'm going to take that perfect square out of the denominator. I'm going to call this 2 over radical of 4 times 2x. And of course that 4 is going to come out as a 2. So now I have 2 over 2 times radical 2x. This 2 came from this radical 4. All right. Now these 2's cancel. So now we have 1 over radical 2x. I'm working magic marker. I'll put this way. All right. And we need to rationalize that denominator. There's nothing we can do with this denominator. There's no perfect square factors in there. So we're going to multiply this by radical 2x over, well, under radical 2x. So we're multiplying this value by 1, and we wind up with radical 2x over, well, 2 times 2 radical, that's going to be just a 2 outside, and x times x is x squared. Radical of that is 2x, and we're done. So that's some examples of rationalizing the denominator. In each case, we have created maybe a radical in the numerator. There's radicals in the numerator here, but there's no radicals left in the denominators. And that's what we're looking for. That completes this chapter. Have fun with the homework. See y'all later.